Hello students, today's agenda is to check homework. We'll be learning about absolute value functions, and today's students will be able to write absolute value functions as a piecewise function. So even though we're doing the piecewise function, we're going to be reviewing a lot of the concepts that we have learned in the previous couple of lessons. We're going to be doing transformations, we're going to be doing the domain and range, and creating the piecewise equations. So several concepts combined here. Okay, the first thing that we want to do is to do or create the transformation. We already have the mother graph in here of y equals the absolute value of x. Okay, just the parent graph. They call it either the mother graph or parent graph. And so when we have a subtraction outside of the absolute value, that means that my graph is going to go down 5 spaces. And so I just grab the vertex and go 1, 2, 3, 4, 5. We know that each point in here goes from corner to corner, meaning that the rise and run is 1 over 1, 1 over 1. And we can just actually connect those points. That's my new graph, and that's what we're going to be creating the piecewise equation. So that's the new graph, and that's what we're going to be creating the piecewise function. And so for this one, we're going to be creating one equation and then one for this one with their limitations. So we can either put f of x or y. I'm just going to put y equals. We look at the initial point. The initial point is where will that graph, that line, touch the y-axis. So it's at -5. Always put the x, and then we'll figure out what the slope is. For that piece, just look for any 2 points, and you can even just highlight the points. Always start counting from the left vertically, how many movements and in what direction this one moves. Start from the point on the left, go down 1, that means -1 over 1. So you would put -1 over 1, but because the 1 over 1, we don't need to put it in the equation, we just put negative. Okay, when we graph it, we put -1 over 1. The limitations or constraints is if x is related to where is the value of x. And some people are still confused about that. Just look at this point where that line ends and give me the values for that point. Well, for x is 0, -5, 0, -5. The number that we're going to use is the value of x of that point. So it's 0. Now, not having that in mind, 2 tricks. If it's on the left side, going on the left side, then you're going to put less than. Another way to think about it is look at where this is pointing. Is it pointing to the west or to the east? It's going to the west, so that's where this should go as well. This should point to the left. One more thing that we need to remember is that if the 2 lines touch at one point, then we're going to include equals for one of the 2 constraints, okay, of the 2 equations. Now we're going to ignore that part or that piece of the function. Now we focus on this one, and the initial point is again at -5. We put the x and then find the value of the slope. Look for any 2 points. It doesn't matter. I can choose from here all the way to here and then simplify. The closer, the easier for you. But it's choosing points that are exactly at corners of those grids, okay? And we notice that from the point on the left, right, the point on the left, we start counting always vertical first and then horizontal. So it goes 1 up and 1 to the right. 1 over 1, we don't need to put it, so just positive x. And then we put if x is, again, we covered this part that we're not doing that anymore. X minus 5 is this equation. Again, look at the arrow. People say, oh, it's pointing up. We're not talking about up or down. We're talking about left or right. Well, it's kind of like to the right. So this points to the right. Look. It's like the arrow is going that way. This part looks exactly like this. This is pointing on that direction, okay? And again, it started exactly at 0. Your assignment is asking to write the piecewise function of this absolute value function. A piecewise function from that absolute value function. For the domain, well, if it kept going, we include all of the x values. So that means that all real numbers are included in here. For the range, which are the values of y does it include arrows up and down? No, we don't have anything going down. That means that this is the beginning. Starts at -5 and then it goes up. With the arrows, it shows that it will keep going all the way to infinity. So that means that it's greater or equal than the value of y now, which is -5. Okay, so from -5 and up, we have points. But from here down, we don't have any points. Before we move to the next one, something else that I want to highlight. Again, where the point meets, that's where we have one has to have the equal sign and one doesn't have to have it. It doesn't matter which one. I'm putting it on the first one, however. And one other thing that they asked me, teacher, what if I put this one at the bottom and I have this equation on the top? As long as this matches with this one and this matches with this one, that's okay. The only difference that can change or vary is having this equal on the first one or the second one. Some people will have it here, some people will have it here. But this has to match with this constraints and this has to match with this constraint. For the next one, we have 1, 2, 3 transformations. These two are translations and this is a mirror or reflection. So the first thing that I recommend is just doing the dots for the reflection. So this is 0. Instead of +1, it's going to be on the -1, and then it's going to open like this. Again, that's just the reflection, so I cannot graph the entire new graph, okay? It's going to go like that, just with this. Now for each point, remember that inside, if it's addition, it goes to the negatives, and if it's subtraction, then it goes to the positives. Inside is related to x, and it's opposite. Outside is on y, and it does what it says. If it's negative, it goes to the negatives. If it's positive, it goes to the positives. In this case, because it's negative, it's going to go down, and this one, instead of going to the right positive, is going to go to the left. So every point in here will go 4 spaces to the left and 1 down. I just work with the vertex and move it 1, 2, 3, 4, and 1 down. Okay, so my graph will go like this. Why am I doing this? Because we know that each point is just on every corner. I'm using a different color so that I don't get confused. Okay, and then now I'm able to create the graph. So this is the mother graph, and here we created only the reflection, and with the translations, it moved to the left and 1 down. Okay, so that's where we're going to use to create our piecewise function. Again, we can put y equals or f of x equals, and we're going to look for this one first. But we need the initial point. The initial point is always where it touches the y-axis. So I notice that it goes 1 up and 1 to the right, 1 up and 1 to the right, 1 up and 1 to the right. It will touch here if we extended it, okay? So the value is 3. It's positive, and always put the x. And from any point to any other point, it goes up 1 and 1 to the right. So that means that is 1/1, positive. We don't need to put it. The constraints is if x is From where do we have this graph? Well, starting right there. Look at the value of x is -4, so it's -4 in here. Now the other thing is, look at the arrow. Is it pointing to the left or to the right? We don't say that it's up. We wouldn't draw this up or down, right? It's to the left or to the right. Well, it's pointing on the left, so this points to the left as well. That way, that way. And this means x is less than -4. Again, we can, because these two lines meet in that point, we can include the equal in any of the two constraints. For the next one, ignore all of this. This one is touching the y-axis, so that means that we have the initial point, which is -5. And from any point to any other point, it goes down 1 and 1 to the right. That means that it's going to be -1/1, but we just put negative. The 1/1, we don't need to put it. If x is the same at -4, because they meet right there, but where is that pointing? To the left or to the right? It's pointing to the right. Because we put the equal in here, we don't need it in here. What is the domain for this new absolute value function? Well, because it's pointing, it means that it goes on and on and on and on. So all the values on x are included. What is the range? For the range, well, it's just from here down. It doesn't have anything on the top. Remember that this is not being considered. So it's from here down. Well, for y, it's a -1. Y, and it's less than because it goes down. Less than or equal, because that one is close to -1. We can touch the values down here. If I go up, we're not touching the graph at all. Okay, so it's only below that -1. For number 3, we have a reflection, a stretch, and then we have a translation. Inside, the translation goes on the opposite direction. So since it says -3, instead of going to the negatives, it's going to go to the positives. In here, when you have a stretch and a reflection, you can just multiply the entire thing. -4 times the value of y. Okay, the value of y. So 0, 0 stays at 0 because -4 times 0 is 0. -4 times this space is 1 for y. Remember that outside is always related to y. Multiply that value by -4 is -4. We start counting from the x-axis. -1, -2, -3, -4. The spaces of y in here is 2 times -4 is -8. So we go back to the x-axis and start counting -1, 2, 3, 4, 5, 6, 7, 8. It's a -8. On the other side, it's going to be the same, but remember that the absolute value is symmetrical, so we can just graph them on the other side of that vertex. So if I only had -4 in here, that will be my graph. However, it says move those points after you do the stretch and reflection, move it 3 spaces to the right. We use a different color so that we don't get confused. So from here, 1, 2, 3, right there. This point, 1, 2, 3, right here. This point, 1, 2, 3, right here. This one is 1, 2, 3, here, and 1, 2, 3, right here. Now we're able to draw our graph. For our function, our piecewise function. What is the initial point? Well, we have to extend this one, and we know that it goes down 4, -1, down 4, -1. So that means that it will touch at -12, right? Because it goes 4 more spaces. From -8, it goes 4 more spaces, -12. For the slope, for this side, start counting from the point on the left. It goes up 4 spaces and 1 to the right. 4 over 1. It's positive because it goes up, but we don't need to put the 1 as denominator. For the constraint, what is the value of that point right there? Because we're talking about this. It's going from to the left of that point. What is that point? The value for x in there is 3. Where is this pointing? More towards the left or to the right? Towards the left. And then we can include the equal in this one or the second one, okay? For the other one, again, we're talking about it goes up 4, 1 to the left, 4, and 1 to the left, 1, 2, 3, 4, 1 to the left, and 1, 2, 3, 4, 1 to the left. That's where it would touch. It's at positive 12. We just include the x, and then from any point to any point, ignoring that side, from any point to any point, start counting from the left. Always move vertically first and then horizontally. The right is negative 1, 2, 3, 4 over 1. So it's just negative 4 over 1, but we don't put the 1 as denominator. If x is what? Well, at x, aligning it to that point, the highest point or lowest point of that arrow is right there. The value of x is 3. And is it pointing to the more towards the left or to the right? Well, it's pointing more towards that side, right? It's moving eventually to the right. So greater than. What is the domain? The domain, again, it keeps going. That means that for the values of x, it includes all real numbers. For the values of range, y will be, starting at that point, does the graph go up or down? It goes down. So compared to my y, it's at 0. So y is less or equal than 0. Okay, it's not on top of the 0, it's below the 0. The last one, remember that outside is a stretch. We're multiplying the values of y times that number, and then after that we can just move this one. Since it's positive, it doesn't go to the positives. It goes on x and to the left, okay? So let's do the stretch first. 0 times 3 is 0. 1 times 3 is 3, so we count 1, 2, 3. And the same on the other side. 3 times 2 is 6, so 2, 4, 6. And the same on the other side. And then 3 times 3 is 9, so 3, 6, 9. And the same thing on the other side. We use a different color to move all the points to the left, one space. So this one goes here, this one goes here, this goes here, this one goes here. This one will move this way, and this way. We can create our graph. And that's our new graph. That's what we're going to be finding the function, the piecewise function for. Okay, the initial point for this line, well, we have to extend it, right? If you notice, it's going 3 down, 1 to the right, 3 down, 1 to the right, 3 down, 1 to the right. That's where my y-intercept is. So it's -3. Just put the x. And we already said that from any point to another point, starting from the left one, it goes down 3 and 1 to the right. So it's -3 over 1. We don't put the 1. If x, where is the value of x for the vertex or for the first point of that arrow? It's a -1. Is it pointing more towards the left or to the right? Towards the left. So this points towards the left. See, it's like that is part of that arrow. See? Okay, so x is less then -1. Again, because that point is shared by both lines, then we can include the equal in the top one or the bottom one. It doesn't matter, only one of them. For the next equation, we covered that part. What is the initial point? Is right here, a +3. And what is the slope? From any point to any point, remember, always start on the one on the left, and then start counting 1, 2, 3 over 1. That's +3 over 1, but we don't put the 1. If x is, again, that same point is shared by both. It's a -1, but where is that pointing? More towards the left or to the right? That way. So it's greater than. For the domain, again, those lines will continue. That means that it's open, and it's all real numbers. For the y, it's pointing up, but not down, so that means that it starts from the lowest point up, is greater than that. What is the value of y compared to that lowest point? Well, it's aligned to the 0. So for the range, y is going up, that means greater or equal than 0. Okay, with this we end our lesson. If you can support our channel by giving us a thumbs up, subscribing around here. This is the link to the entire unit, and here you will find the next lesson. Now you're able to practice on your own and have fun.